Hi everyone, so let's solve a daily Lead Code challenge question. 70 climbing stairs. So I've also not done this question before. Let's see what the question says. You are climbing a staircase. It takes n steps to reach the top. Okay, and each time you can climb either climb one or two steps. In how many distinct ways can you climb to the top? Okay, so the question is basically saying that there is a staircase and I have to reach to the top. There are stairs and I can climb either one step at a time or two step at a time. So I can climb. So suppose if you number step 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, or say just for the sake of simplicity, 1, 2, 3, 4, 5. Then I have to reach to step 5. Then I can either go from 1 to 2, 2 to 3, 3 to 4, 4 to 5, or I can go from 1 to 3, 3 to 4, 4 to 5, or I can go from 1 to 2 to 1 to 3 and 3 to 5, because so at every step I can take either two steps or one step. So in how many distinct ways can I climb? Good question. If n is equal to 2, and then if n is equal to 3, then what is the question? So here the example I'm giving is n is equal to 5, then what is the answer? Good question. Let me think about the answer then. N is equal to 5. How will I solve this? Uh, if I go from here, then it will be, isn't it like number of ways to climb from step 1 is equal to number of ways to climb from step 2 plus number of ways to climb from step 3, right? So suppose from step 2 I can climb up to 5 in one way. There's only one way. Suppose from or say like 3, there are suppose 3 ways. Suppose from step 3 there are 2 ways. And I know that from step 1 I can either reach to step 2, or I can reach step 3, right? So it means that it will be number of steps to climb from step 1 will be, if I go through the route 2, then there will be 3 ways. If I go through the route 3, then there will be 2 ways. So total will be 5, right? Isn't it? Am I right or not? Step 1, there is step 2 and step 3. If I go through so if I miss step 2, then there are 2 ways to go there. Step 3, then the step is there. And two ways to spell. Suppose that I am at step 4 and 5, right? So if I'm step 4 at step 4, then there is just one way, right? And suppose if I'm in step 3, then there will be either I can reach here and then here, or I can directly reach here. So there will be 2 ways in total. What I'm thinking is like, should I do 1 plus, or is this sufficient? Suppose if it is 6, the number of steps to reach from 5 is 1. From 4 it is two ways, right? There are two ways. From go to 5 and 6 or go directly to 6. So what are the steps from 3 to reach? Will it be 3 or will it be 4? It will be, if I go through step 4, then it will be 1, number of ways, 1, 2. Oh yeah, so this formula is accurate. I'm just checking this formula works or not. So this formula is accurate. So suppose if I'm going through from 3 and so number of way from 4 to 6, from 3 to 4 it is the same, right? So if I go this path or this path, it is the same because in way it's same. If I'm going from 4 to 6, if there is two way, then if I'm going through 3 to 4, then it is the same way. So if there are two ways, right, and since I'm going from 3 to 4, there is one way, so it is the same way, right? 1 and 2. I was thinking if I have to add this branch or not, but I do not need to add because because I'm calculating number of ways, and number of ways is 2 only. Even if I go from 4, there is 1, 2. Even if I'm going from 3, there is 1 and 2. So this is the formula. Yeah, and number of ways to climb from step n to n will always be equal to 1, and number of ways from n minus 1 to n will be equal to 1, and number of ways from n minus 2 to n will be 2, right? Because I can either go from here and then, yeah. So if I have this information, then I just need to step backwards, isn't it? Up to 1. That's great. So what I need to do is uh, time state functions. So what I'm doing here is, suppose if it is 1, 2, 3, 4, 5, then suppose if it is 1, 2, 3, 4, 5, or let's say uh, for easier 1 n is equal to 3, then I think this is called dp, right? Or what should I call it? I number of ways to, I can say number of ways from n will be equal to 1, number of ways from n minus 1. So I'm given n minus 1 will be 1, number of ways from n minus 2 will be 2, right? And there will be a formula, x will be equal to x plus 1 and x plus 2, right? um, so I think I need to go from last. I need to come, I mean, if n is equal to 5, then I need to come back from last, okay? From 5, 4, I think I need to start from n minus 3 here. So 5 minus 3 is 2. So I will have to start from 2. And in this case, number of ways for 2 will be equal to um, 2 will be equal to number of ways 3 plus number of ways 4, right? Number of ways 3 plus 4. So yeah, that's the thing. And then I will do number of ways 1, and number of ways 1 will be the answer. So let's do, let I is equal to 0, I is equal to n minus 2, I is less than or equal to 0, or is greater than So I will go till 1, right? 1 and a plus plus, or I can say step is equal to n minus 2 and step is greater than step minus minus actually. And then I know that number of ways. Maybe I can just build an array, new of array of length n, because it goes from 1 to n, right? And that fill with 0 in the beginning. And I can just say, I don't even need to fill, right? Why do I need to fill? Mm, can just say that number of ways for n, for the last number, because it starts from 1 to n, right? Oh no, it starts from 0 to, so I'll just say um, n will be equal to 1, number of ways, n minus 1 will be equal to, so suppose the length is 5, okay, then the total length will be 6, and number of ways, because this is an array, number of ways 5 will be equal to 1 in this case, and in this case number of ways 4 will be equal to 4 is also 1, right? So okay, and it starts from n minus 2, so it starts from 6 minus, I think it starts from n is equal to 5 here, right? Since 5 and 4 is already done, so it starts from 3, so 5 minus 2 is 3, and number of ways step, this will be equal to number of ways step plus 1 plus number of ways step plus 2, right? So we already have n and n minus 1, so for n minus 2 it will be um, plus 1 and plus 2, so it will give me that answer, and it will go up to 1, right? So and the answer will be equal to number of ways of 1. Mm. And if n is equal to 2, then 2 will be 1, and if there are two states, right, from 1 to 2, it takes n steps to reach to the top. It means, okay, so it looks like it took n steps to reach to the top. It means this is top, first step and second step. Okay, so it means that again, let's put that new array is equal to n. Because I thought that n is the total number of steps, but no, it looks like n is the, n is not the total number of steps. if this is top, then if this is top, then 1 to 3, then you can just build 3 array and then number of steps. Mm, Actually, I just kept every code the same. I only did n is equal n plus 1 because I thought that n is the number of steps before. But here they are saying that n is the number of, you know, number of ways that I can reach to the top. So I should do n plus 1, where n is the number of steps. Now n will be the number of steps, right? That's what I changed here actually because I misread the question, so this is what I changed. Let's look at the solution. And by the way, time complexity and space complexity will be O of n, and space complexity will be O of n only. Yeah, recursion with memorization. Actually, I actually drew the recursion tree as well, right? One time because I was trying to find the formula here. Should I do 1 plus or not? So at the time, to be clear, I had drawn a recursion tree. From 3, if there are 2 ways, then from 2, how many ways will be there? I was trying to know about that. Yeah, this is a good recursion question. Number of ways. I did not know how to think about recursion. I just thought about this uh, this dynamic programming directly because this is so the easy one. But if I had to do with recursion, then how would I do it? It's a similar way actually because from one to two. Yeah, it's the same thing, right? From one, so I will just start from one, and then from one it would be this two plus number of is three, and from two it would be number of is plus this one. So idea is the same, but in recursion, instead of trying to going from bottom to up one, I'd go from top from one to at till the end. But the basic idea is same. Like this formula, it is the same. Number of ways to climb from one is equal to number from steps from step two plus step three. This formula, this is the actually this is the recursion formula that I would used in recursion top down approach. From one, from two plus three, and I would have calculated for two, then three, similarly. But here I did from bottom to up. dp3 is equal to dp2 plus dp1 is equal to 1. Hmm. There are so many other methods, but I will not look at the other methods. That is true though. Math node. Mhm. Now, total number of ways to reach ith is equal to the sum of ways of reaching I minus 1th step and reaching I minus 2th step. Mm, so total number of ways to reach this one is equal to total number of ways to reach this one plus total number of ways to this one. Total number of ways to reach 5 is equal to total number of ways to reach 4. Oh yeah, like this is a little bit different than mine. I said to reach here it will be this plus this. I mean, from reaching from 3, if I need to reach to anything, then it will be 4 plus 5. Simple 2-minute meditation. I just got a notification in the Apple Watch, and it wants me to do a 2-minute meditation. Wait, I will do it after this session. Mm, so yeah, oh my god, I'm talking with such depleted energy. Three, four, five, six. So the way I did was the number of steps to reach number of steps to reach to the top from 3 will be equal to from 4 plus 5. What they are saying is single step from, okay, it is similar. Okay, I will just try to refresh the concept of dynamic programming. So dynamic programming means can be broken into sub problems. Yeah, because I did this right. Number of ways to I did break into sub problems, and it contains the optimal substructure property. Its optimal solution can be constructed efficiently from optimal solutions of its subproblems. Okay, so dynamic programming means this. Okay, I can divide into subproblems, and one problem can be solution of one problem can be um, I can get the solution of one problem and the solution of other subproblems. Of course, so that is what dynamic programming is. Mm, this one, these are the subproblems, and I could get a problem from each subproblems. Just taking help. Okay. Uh, thank you so much for watching, everyone, and so I will do today's daily tour challenge also. Actually, this was yesterday's question, and today's question is this. I wanted to do yesterday's question before doing today's question, so I will start doing today's question uh, after stopping this streaming. So see you soon. Bye.